Okay, so question 36, we've got start of integration here. Okay, now if you look at part 1 here, and this looks sort of like a bit awkward, right? You might be wondering how on earth you're going to go about this, because it's like a quotient, isn't it? You've got some function on the top, function on the bottom. What you can do, right, because everything on the top here is divided by x, you can split this up, okay? And that's what I'd advise you to do, and deal with the terms separately. So before you integrate, divide each term by x. So 7x squared divided by x. Take away 2 divided by x. Okay, so each term on the top divided by the x, dx. And again, before I'd integrate, I'd simplify this. X squared divided by x is just x. And 2 over x, well, I would leave it as 2 over x. Okay, because remember, when you've got x on the bottom to the power 1, when you integrate them, we're going to have ln, aren't we? So when I integrate this now, I'm going to have 7x squared over 2, right? Raise it by 1, and then divide by that new power. Then this, remember, then is ln, yeah? So it'll be minus 2 ln x, okay? And that's it. And don't forget your nu plus c, okay? If you forget that, you're going to lose a mark, so please be careful. You know, just double check at the end. You've got to think, have I done everything with integration? Is everything there that it needs to be? When there's no limits, you've got to have a plus c, so always double check at the end, right? That's when I finish this, I'll say the same thing again, I'll check, okay? So part 2 now, you've got sine. Okay, now when you integrate sine, sine becomes minus cos, right? It's the opposite idea to differentiation, right? So when you differentiate, you know cos becomes minus sine, right? You know where that minus comes in. But then when it comes to integrating, the opposite things happen. So sine becomes minus cos when you integrate. So minus cos of all this nonsense here, right? That stays there in here. But you've got to make sure then you divide, yeah? You divide by the derivative in here, which is 2/3, okay? Right? And don't worry about the pi, it's a constant, but you differentiate whatever's in front of this x here, you put down here basically, okay? And then don't forget your c. And then, you know, simplify it, so maybe, you know, flip this, because there's a fraction at the bottom, take the 3 up. I would do that, okay? Right, I would definitely do that. Divide them by 2 plus your c, okay? Question B then, it says to evaluate, and now we've got limits, okay? The fourth root of 5x minus 14 dx. So in the question, they've got a bracket in there, in that fourth root. I wouldn't worry too much about that. But maybe it's giving you a bit of a hint anyway, because that's what we've got to do, isn't it? You know, in order to get anywhere near this, we've got to write this as a bracket, 5x minus 14 to the power quarter, right? That's what the fourth root is, yeah, power quarter. And then, of course, to go further with this now, you need to take that up, okay? So it becomes minus quarter dx, okay? That's what you need to do, of course, and then we can integrate it. Now when you integrate, brackets, don't forget, you add the power to this, so you add 1 to it, sorry, you add 1 to that, you get 3/4, divide by this new power, which is 3/4, times then by the derivative in here, which is 5, okay? And then we don't need to add c on, right, but what we do need to do is put square brackets around here to put the limits in, okay? And before I do the limits, I might tidy this up a little bit. Now on the bottom there, 3/4 times 5, well that becomes 15 over 4. So 15 over 4 here, flip that fraction, so it'll be 4/15, okay? Alright, so that's what you get there. And just to finish off then with this, you need to put the limits in, okay? So the limits then, substituted in here, so we put 6 in first. So put 6 in there, 5 times 6 will be 30. Take away then 4/15 and put 3 in, so 5 times 3 is 15. Okay, so I'm going to use my calculator on this. Perhaps what I'll do, simplify this a bit, because that's going to be 16, isn't it? That's just going to be 1, isn't it? So that's nice. 1 to the power 3/4. Okay, so I'll type that in. 4/15. 16 to the power 3/4. Okay, minus then 4/15. And actually it's just 4/15, isn't it? Because that's going to be times 1 in the end, because the power 3/4 is still 1. you get 28 over 15 as my answer, so you can leave it like that and we're done. Now just to double check, right, there's your answer, right, as I said, priorities then, once you've got your answer there, just check, have I got my constants in place, okay, just remember I said that, double check, constants are in place, yeah, constants are in place for part 1, for part 2, you do not need it for part B because there's limits, but you've got them here and you've got to be in place everywhere, alright.